In this video, we're going to take a look at another factoring technique, which is called factoring the difference of squares. I want to remind you, or maybe review, some multiplication that we did. This was kind of a shortcut. It was called a special product of sum and difference. Do you remember when we multiplied x, say x plus 3 times x minus 3? It had to be a sum and a difference of the same quantities. When you have this, and if you think about FOIL, the product of the first is x squared. The outer product and the inner product are opposites. And so if we realized that we were dealing with the difference, sum and difference, then we didn't even take time to look at the outer and inner products, knowing they were going to cancel. The product of the last is a positive times a negative, so it's always a minus, and 3 times 3 is 9. The answer that we got as a product was always a difference, because it was minus. This was always the square of the first one, and this term was the square of the second one. It was the difference of squares. So a sum and difference product gives you the difference of a perfect square and a perfect square. I would like to make a list for you of some squares so that you begin to recognize them. 1 squared is 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, 6 squared, 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared, 100, 11 squared, 121, 12 squared, 144, 13 squared, 169, 14 squared, 196, 15 squared, 225. Now, obviously, that goes on toward infinity, and don't forget that x squared, well, obviously gives you x squared. That is a perfect square. So it will help you to recognize these perfect squares as we try to factor the difference of squares into sum and difference products. The first one is x squared minus 144. Now, the difference of squares is always going to be a binomial, 2 terms. This is a binomial. It is a difference because there's a minus sign. X squared is a square. 144, think about your list. Yes, it's a square. So it is the difference of squares, which will always factor into a sum and a difference product. What times what gives you x squared? X times x. What times itself gives you 144? 12 times 12. You could check it. Product of the first is x squared. Outer and inner cancel. Product of the last, positive times negative, is negative 144. Next one, 144 x squared minus 1. It's a binomial. It is a difference. That's a perfect square. Its square root is 12x. That's a perfect square. Its square root is 1. My factors for the difference of squares will be 1 plus and 1 minus. The square root of the first one was 12x. The square root of the 1 was 1. Those are my factors. I get a sum and difference product. Next one, 25 x squared minus 144. It is a binomial. It is a difference. Perfect square, perfect square. 1 plus and 1 minus. The square root of 25x squared is 5x. 5x times 5x does give me 25x squared. The square root of 144 is 12. Those are my factors. Let's look at a few more. I have 169x squared minus 121y squared. It is a binomial. This is a perfect square. This is minus. This is a perfect square. Remember, it has to be the difference. It has to be a minus. All right, so it is going to factor into sum and difference products. The square root of 169x squared is 13x. The square root of 121y squared is 11y. And I'm done. Number 5, I have x squared plus 36. It is a binomial. X squared is a perfect square. 36 is a perfect square. But this is a problem. It is not the difference of squares. It is the sum of squares. The sum of squares is always prime. You can sit there and play and practice with it, all different kinds of factors. You will never get two factors that are real numbers that will multiply together to give you that. Okay, so now number 6 is kind of especially challenging. It is 256 m to the 4th minus a 1. Now, 256, we did not get to that big on my list, but on your calculator, if you put in 256 and take its square root, now depending on the calculator, you might hit that button and then 256, or you might hit 256 and then that button. It just depends on the calculator, but it will give you 16. 16 times 16 is 256. So this is the m to the 4th is a perfect square because it's m squared times m squared. And 1 is, of course, still a perfect square. So this one is a little bit more challenging. The higher power and the fact that 256 is a large number. This is the difference of squares. So I'll put 1 plus and 1 minus. The square root of 256 was 16. The square root of m to the 4th, it would be m to the 2nd, because m to the 2nd times m to the 2nd, add them for m to the 4th. Then I have 1s. Now, here's what's especially unique about this problem. This factor is the sum of squares, which is prime, which means it's a finished prime factor. But this factor is a minus. This is a perfect square, 16m squared. This is a perfect square, 1. This can be factored further. Now remember, we said that the sum of squares was prime, so it's finished. This factor is the difference of squares still. So I'm continuing with just this factor, 1 plus and 1 minus. The square root of 16 is 4. The square root of m squared is m. The square root of 1 is 1. Now, if this had an exponent of a 2, we could go further, but it doesn't. So I am done. This factor was already finished. This factor went further. My answer is all 3 of those factors. This is a challenge. Let me make one up. What if I had m to the 8th minus 1? Okay, well, that is the difference of squares. Anytime the exponent is even, you can split it. M to the 4th times m to the 4th and 1s. Well, this is done. M to the 4th, it's done because it was a plus. But this factor is still the difference of squares. So I can factor it into m squared plus 1 and m squared minus 1, because the square root of 1 is 1 and 1 continues to be a perfect square. Well, This is done, still m to the fourth plus 1. This one is done, m squared plus 1. But this last factor is still the difference of squares. So it will be m plus 1, m minus 1. You see that the exponents, the powers on those m's started getting smaller. And so now, because that exponent is a 1, I can't go any further, but I have to have all 4 factors. So sometimes you have to do many steps to complete your factoring.